Today, we're diving into a massive study on lean manufacturing, specifically looking at Malaysia's construction industry, to figure out how operational excellence is actually built from the ground up. Okay, so here's our game plan. We'll kick things off with the war on waste, trace the birth of lean production, look at building lean construction, dig into the Malaysian experiment, see what the data shows, and finally, wrap it up by redefining waste for good. Let's get into it.
Part 1. The War on Waste.
So we need to start by totally flipping a fundamental concept in operations management on its head. What actually is waste? Now, you might be thinking of a dumpster full of scrap materials, right? Well, it's time to think way beyond just physical trash on the floor. We need to shift our focus entirely to lost time and inefficient movement. I mean, the whole goal of operations management is to transform inputs into valuable outputs. But traditionally, when we think of waste, we literally just picture discarded materials. We absolutely have to rethink that definition.
You know, Henry Ford hit the nail on the head way back in 1926. He pointed out that the hardest waste to correct is the waste of time. And actually, early engineers like the Gilbreths said the exact same thing when they were trying to eliminate delays and other non-transformational activities. Think about it. You just can't salvage lost time. It's completely invisible. It doesn't pile up in the corner of a factory where you can just sweep it away, and yet it's pretty much the most destructive force against operational excellence.
All right, moving on to part 2, birth of lean production. This whole realization about time being waste, it actually sparked a revolutionary manufacturing philosophy, one that was totally born out of post-war necessity. So, picture Japan after the Second World War. Resources are incredibly scarce. That's when Taiichi Ohno at Toyota Motors stepped up and developed what would famously become known as the Lean Production System, or LPS. It's wild to trace this evolution. It grew from those early 1920s observations by Ford and the Gilbreths all the way to Ohno putting it into practice, until finally, in 1989, researchers over at MIT actually coined the term Lean Production System. So, what makes LPS so special? Well, it essentially sits perfectly right in the middle of two extremes. It completely avoids the incredibly high costs of skilled craft production, but at the same time, it totally ditches the super rigid standardization of mass production. It's like taking the absolute best parts of both worlds to create an entirely new paradigm of efficiency. And if you're wondering if this hybrid approach actually works in the real world, oh, it does. MIT ran these benchmarking studies and found a massive 2-to-1 productivity advantage for LPS auto assembly plants compared to conventional plants. Let that sink in. That means they were generating literally double the output with the exact same amount of resources. How? Simply by ruthlessly stripping out any activity that didn't add value. But wait, it gets even crazier. The percentage of failures due to quality problems was a microscopic 0.03% for LPS plants. Compare that to a massive 2.5% for standard mass production plants. By waging this war on waste, the lean production system proved, once and for all, that you do not have to sacrifice quality just to get speed.
Okay, part 3, building lean construction. Let's see how all this theory translates into an entirely different and frankly much messier arena, the construction industry. Lean construction basically takes the exact philosophy of the lean production system and applies it directly to projects delivery. The goal? Create stable schedules, slash costs, and keep customers happy. But here's the catch. A factory floor is a highly controlled environment. A construction site, it's completely exposed to the elements, it's chaotic, it's muddy, so applying factory logic here is a massive, massive challenge. So, to figure out if this theory actually holds water in the real world, researchers launched a major study. They wanted to test 6 specific LPS principles against actual, on-the-ground operational performance in construction. They really wanted to know, which of these pristine, factory-born concepts can actually survive the grit and chaos of a live building site? That brings us to part 4, the Malaysian experiment. This is where we get to our empirical anchor for today, an absolutely fascinating, extensive study of the Malaysian construction sector. Researchers managed to analyze 296 responses from high-level executives at grade 7 construction organizations. Now, just for some quick context, the vast majority of these were private companies located in the Klang Valley. And grade 7, that represents the absolute top tier of construction capability in Malaysia. So we're talking about serious players handling massive, multi-million-dollar projects. The researchers were super smart about this. They specifically targeted true industry heavyweights, like CEOs and project managers. And what they found was a highly educated workforce, but one that suffers from the high turnover rate you typically see in temporary, project-based organizations. Think about it. Because construction relies on moving from project to project, building that deep, long-term organizational culture, which, by the way, was a huge staple of Toyota's success, is fundamentally harder to pull off here.
Part 5. What the data shows. Let's dive right into the numbers to see which of these lean principles actually move the needle on operational excellence. When these Malaysian managers were asked what they rely on the most, they overwhelmingly pointed to continuous improvement. They were frequently using really simple, low-cost project debriefings to learn and improve. It's a very pragmatic, grassroots way to just sit down after a build and say, okay, what went right and what went horribly wrong, without spending a fortune. But guys, here is where the data reveals a total plot twist. While things like multifunctional teams and waste elimination positively predicted operational performance, other methods like rigid supplier integration and forced just-in-time systems actually had a statistically negative impact. Yes, negative. This completely bucks the trend of what we know works so perfectly in auto manufacturing. So why the negative impact? Well, the researchers concluded that without the massive capital required to invest in expensive IT systems and with suppliers often located miles away from fixed construction sites, forcing these advanced lean methods actually slowed these firms down. In a factory setting, the suppliers come to one permanent predictable hub. But in construction, the site moves, traffic is a nightmare, weather is unpredictable. Trying to perfectly time a just-in-time delivery of concrete or steel usually just leads to massive, expensive delays and a whole lot of double handling. Context, as always, is absolutely everything. And our final section, Part 6, Redefining Waste for Good. So, what's the big takeaway here? What is the ultimate gap in understanding that we can pull from this Malaysian experiment and apply to our own daily work? Well, the study found that while these managers absolutely loved the idea of continuous improvement, they totally misunderstood what waste actually was. They were still viewing it only as surplus physical building materials rather than inefficient daily processes. If you're a manager and you're only looking at a pile of scrap wood or excess concrete as your waste, you are totally blind to the vast majority of your actual operational losses. And that brings us back to the true underlying power of the lean production system. In this model, waste is entirely redefined. It is any non-value added time or effort that puts your money to sleep. That's the key phrase right there. It's the time your crew spends just standing around waiting for a city inspection. It's the totally unnecessary transfer of heavy materials from one side of the site to the other. Or it's producing a subassembly 3 weeks before you actually need it. As we wrap up this explainer today, I want to leave you with a provocative question to chew on. Where are the non-transformational delays hiding in your own daily operations? And more importantly, how can you finally eliminate them? Because until we all wake up and realize that wasted time doesn't just litter the floor like physical trash, our true operational potential is always going to remain asleep.